Okay, boys and girls, question number 1. Verify Green's theorem for this, where C is bounded by y is equal to x and y is equal to x squared. The question is saying that C is bounded by y is equal to x and y is equal to x squared. I encourage you to sketch the region C first. So we are going to sketch region C first. This is y, this is x. Y is equal to x squared. This is the line. Y is equal to x squared. This is the curve. This is y is equal to x squared. The two graphs intersect at 2 points, at 0, 0 and at 1, 1. So these are the points of intersection. Okay. If you check, we have two curves. So this is region C. Region C is bounded by y is equal to x. So this is y is equal to x and y is equal to x squared. So I'm going to call this part of the curve y is equal to x squared C1, curve 1. Okay, and from here to here, this is curve number 2. So I'm going to call it C2. Okay, now we want to find the integral over curve C1. Okay, integral over curve C1. After finding the integral over curve C1, we are going to find the integral over curve C2. So over curve C1. This is y is equal to x squared. You find dy by dx. Dy by dx is 2x. Okay, now dy is equal to 2x into dx is equal to 2x into dx. Why am I doing this? I want to get rid of one variable in this function. Okay, so I'm going to get rid of y. So I'm going to substitute where there is y by x squared, and I'm going to substitute where there is dy by 2x into dx. This becomes the integral x into x squared plus x squared to the power 2 dx plus x squared into 2x dx. Okay, now what is the lower limit of x and what is the upper limit of x? The function is now in terms of x. So the lower limit of x is 0, the upper limit of x is 1. The integral from 0 up to 1, x cubed plus x to the power 4 plus 2x to the power 3. 2x to the power 3 dx. This becomes from 0 up to 1, 2 plus 1. This is 3x cubed plus x to the power 4 with respect to x. Okay, let's integrate this. This becomes 3x to the power 4 by 4 plus x to the power 5 by 5 from 0 up to 1. Okay, this becomes 3 over 4. This is equal to 3 over 4 plus 1 over 5. Subtract. If you substitute here, it's 0, 0. So subtract 0. 3 by 4 plus 1 by 5. The answer is 19 by 20. 19 by 20. Okay, we are going to do integration over curve C. Now over curve C2. Okay, remember this is y is equal to x, so dy by dx is equal to 1, dy is equal to dx. Dy is equal to dx. It's now the integral. Substitute for y by x. So x, this becomes x squared plus x squared with respect to x plus x squared with respect to dx. Remember, if you check here, dy is equal to dx. So you're going to write dx. The function is now in terms of x. So what are the limits? The lower limit of x is 1 and the upper limit of x is 0, because we are moving from here to this. Check the arrows. Okay, this is the importance of the what? Of these arrows. They are telling you the direction. So we are moving from x is equal to 1 up to x is equal to 0. So 0 is the upper limit, 1 is the lower limit. So this is the integral from 0 up to 1 to x squared, or this is x squared plus x squared, okay, plus x squared. It becomes 3x squared with respect to x. If you integrate this, this is 3x to the power 3 by 3, okay, from 1 up to 0. If you check, okay, this is 1. So this is 0, subtract 1. So the answer is negative 1. Okay, so the total integral is equal to the sum. In the first part, the integral over curve C1 is 19 by 20. Okay, plus the integral over curve C2, which is negative 1. So 19 by 20 plus negative 1. The answer is negative 1 by 20. So this is the answer from the left hand side. This is the answer from the left hand side. Let's check the right hand side. Consider the right hand side. Compare this function and this. So p is equal to xy plus y squared. Q is equal to x squared. The partial derivative of p with respect to y. Okay, we are going to find the partial derivative of this with respect to y. This becomes x plus 2y. The partial derivative of q with respect to x, this is 2x. Okay, so here this is dx dy. So I am going to use a horizontal strip. This is the horizontal strip that I'm going to use. So the upper limit for x, okay, the upper limit for x, if you check, the upper limit for x is root y. Remember, this curve is y is equal to x squared, so you make x be the subject of the formula. X is equal to root y. And the lower limit for x, is equal to y. Okay, now the upper for y The upper for y is 1. The lower limit for what? The lower limit for y is 0. Okay. Substitute double integral. This is 2x minus x plus 2y dx dy. The lower limit here is y. The upper limit here is root y. This is 0. This is 1. Integral from 0 up to 1, from y up to root y. 2x subtract x. The answer is x plus 2y dx dy. So we are going to integrate 2x subtract x. The answer is x. Okay. Negative is affecting this again. Okay. So this becomes negative 2y. Okay. Let's integrate this with respect to x. From 0 up to 1. X squared by 2 minus 2y x from y up to this with respect to y. This is equal to 0 up to 1. Substitute for x by this. So this is root y to the power 2 is 1 minus 2y into root y. Subtract, this is y squared by 2, subtract 2y into y with respect to y. Okay, this is 0 up to 1. This is y squared. This is y by 2. Okay, this is minus 2. Y to the power 2 over 2. Y to the power half. So this is y to the power 3 over 2. Minus, this is y squared by 2. And this is negative 2y squared. This is negative 2y squared dy. Okay, let's move on to the next. We have to simplify this. Okay, I'm going to use this part. This is the integral from 0 up to 1. Y by 2 minus 2y to the power 3 over 2. If you simplify this, this is negative y squared by 2. Okay, you can solve here, but I'm going to write it like this. Okay, negative y squared by 2 plus 2y squared. This is positive 2y squared with respect to y. So let's integrate this with respect to y. This is y squared by 4 minus, this becomes y to the power 5 over 2. So you are going to divide by 5 over 2. So this is going to, we are going to divide this by 5, then here it becomes 4. Subtracting here, this is y to the power 3 by 6. Y to the power 3 by 6 plus 2y to the power 3 by 3 from 0 up to 1. Substitute, this is 1 by 4, subtract 4 by 5, subtract 1 by 6 plus 2 by 3. Subtract 0. If you substitute for y by 0, this thing becomes 0. This is 1 by 4, subtract 4 by 5, subtract 1 by 6. Okay, the answer is negative 1 by 20. If you check, the left hand side is equal to negative 1 by 20, the right hand side is equal to negative 1 by 20. So now you can give the conclusion. Okay, you write, since the LHS, the left hand side, is equal to the right hand side, Green's theorem is verified. Okay,